Hello everyone. Today I am here with you all with the 8th chapter of class 9th maths, that is quadrilaterals. We are already having videos on the first 7 chapters of class 9th maths. Along with that, we are also having videos on all the topics of class 10th maths also. So for more and more videos on various topics of maths, please do subscribe my channel. So let's start with the topic quadrilaterals. So first of all, what quadrilateral is? Quadrilateral is basically a polygon that means a closed figure which is only made up of line segments, and if the number of line segments is 4, then such type of polygon is known as quadrilaterals. So a quadrilateral is a closed figure which is having 4 sides, 4 vertices, 4 angles and 2 diagonals. Suppose there are 4 points are there, and if all the 4 points are your collinear, then joining these 4 points we can make a line. A line can be obtained by joining these 4 points because these 4 points are collinear. If out of these 4 points any 3 are collinear and one is somewhere else, suppose it is here, if these are the 4 points, if we will be joining these 4 points, then we will be getting a triangle. And suppose there is none 3 points are there which are collinear, that means all the 4 points are lying somewhere like this, then if we will be joining these 4 points, then we will be getting a 4-sided closed figure which is your quadrilateral. So a closed figure which is made up of line segments and it is having 4 sides are known as your quadrilaterals. Suppose it is your quadrilateral A, B, C, D. So a quadrilateral will be having 4 vertices. So vertices will be A, B, C, D. These are the vertices of the quadrilateral A, B, C, D. So it will be having 4 vertices, that is A, B, C, D. It will be having 4 sides, that will be AB, BC, CD and AD. These will be the 4 sides of the quadrilateral, that is your AB, BC, CD and AD. These will be the 4 sides of the quadrilateral. There will be 4 angles. The angles will be your angle A, angle B, angle C and angle D. These will be the 4 angles of the quadrilateral and it will be having the 2 diagonals. So what diagonals are? If we will be joining 2 opposite vertices, then we will be getting a diagonal. Over here A and B are the adjacent vertices, A and D are the adjacent vertices. So whenever we are joining the adjacent vertices, we are getting sides of the polygon. Now over here, when we will be joining the opposite vertices, then the line segment which we are getting is your diagonal. So over here, we will be getting 2 diagonals, that will be your AC and BD will be the diagonals. So this is a quadrilateral. So what quadrilateral is basically, it is a closed polygon, closed figure which is made up of line segments and it is having your 4 sides, 4 vertices, 4 angles and 2 diagonals. So in this chapter we will be learning about various types of quadrilaterals and various properties related to your quadrilaterals. Now let's see the angle sum property of quadrilateral. We have learned in the previous chapter, that is your triangles, that the sum of all the angles of a triangle is your 180 degree. So suppose I am taking a quadrilateral. Suppose this is a quadrilateral A, B, C and D. If I will be making any of the diagonal, either AC or BD, so this quadrilateral can be converted into 2 triangles. Suppose I am making a diagonal BD. This BD is one of the diagonal. Now this quadrilateral ABCD is divided into 2 triangles. One is your ABD. This is one of the triangle. Another triangle will be your BCD. Now suppose I am naming it as angle 1, angle 2, angle 3, angle 4, angle 5 and angle 6. These are the angles. So if I'll be considering in triangle ABD, what angles are? Angle 1, angle 2 and angle 3 is the 3 angles of your triangle ABD. So we know that the sum of all the angles of a triangle is your 180 degree. So angle 1 plus angle 2 plus angle 3 will be your 180 degree, because sum of all the angles of a triangle is your 180 degree. Suppose this is your equation number 1. Now we will be considering another triangle, that is your BCD. So in triangle BCD, there are again three angles are there, angle 4, angle 5 and angle 6. These four angles are there, three angles are there. So if we will be adding these three angles, then sum of all these three angles will be your 180 degree, because sum of all the angles of a triangle is your 180 degree. So this is the triangle BCD, and sum of all these three angles, that is 4, 5 and 6, will be your 180 degree. Now if we will be adding equation number 1 and equation number 2, equation number 1 plus equation number 2 if we will be doing, so LHS part will become angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 will be 180 plus 180. This will be the equation. Now angle 1, we know the angle 1 is your angle A itself only. So angle 1 could even be written as angle A. 2 plus 4, if we will be adding angle 2 and angle 4, we will be getting angle B. So angle 2 plus angle 4. If we will be adding these two, it will become your angle B. Now angle 3 plus angle 5. If we will add these two angles, it will be your angle D. So angle 3 plus angle 5 is your angle D. And angle 6 is your angle C. So it is your angle C. 180 plus 180 will be your 360 degrees. So we can see over here angle A plus angle B plus angle C plus angle D is your 360 degrees. That means we can say that in a quadrilateral, sum of all the four angles will be your 360 degrees. This is how we can prove it, even that if we will be taking any of the quadrilateral, if we will be making any of the diagonal in this quadrilateral, it is going to convert it into two triangles. Now by proving, by verifying like this, that sum of all the angles of first triangle will be 180 degree, sum of all the angles of second triangle will be 180 degree. If we will be adding it, we will be getting that sum of all the four angles of the quadrilateral will be your 360 degree. So it is very important property of a quadrilateral that sum of all the angles of a quadrilateral is your 360 degree. Now we'll be learning about various types of quadrilaterals and their properties. Now let's understand various types of quadrilaterals. So there are basically three types of quadrilaterals are there, that is your trapezium, parallelogram and kite. All these three are various types of your quadrilaterals. That means all these three are closed figures which is only made up of line segments and are having your four sides. So your trapezium is even having four sides, parallelogram is even a four-sided polygon, and kite is even a four-sided polygon. So let's understand about all these three. First of all, we are talking about trapezium. So any of the closed figure with four sides, and if one of the pair of opposite sides is parallel, there are four sides are there. So one pair of opposite sides, if it is a parallel, then we say such type of quadrilaterals to be trapezium. Over here we can see that ABCD is a trapezium in which AB is opposite side of your CD, and if AB is parallel to your CD, in that case such type of quadrilaterals are known as your trapezium. In this, your AD is not parallel to your BC. That means another pair of opposite side is not parallel to each other. Only one pair of opposite side is parallel. That is your AB is parallel to your CD. This is only the condition. Now see, if your AD is equivalent to BC, that means if the non-parallel sides are equal, this is the only the trapezium. Now if your non-parallel sides, that means your AD is equivalent to BC, then such type of trapeziums are known as isosceles trapezium. It is your isosceles trapezium. If this is the condition, that means if your AD becomes equivalent to your BC, so your trapezium will be your, suppose this is your A, B, C, D. Here AB is parallel to your CD and AD is equivalent to your BC. If this is the condition, then such type of trapeziums are known as your isosceles trapezium. So what's all the properties of isosceles trapezium is, then in the isosceles trapezium, your base angles are equal. That means angle A will be equivalent to angle B. These two angles will be equal. angle C will be equivalent to angle D. These are the base angles, they will be equal. In the isosceles trapezium, your diagonals are even equal. That means your AC will be equivalent to BD. These are the diagonals. The diagonals will even be equal. And sum of opposite angles will be 180 degree. Angle A plus angle C will be 180 degree and angle B plus angle D will be your 180 degree. All these are the property of your isosceles trapezium. Isosceles trapezium is a trapezium in which the non-parallel sides are equal. If this is the condition, we say the trapezium to be an isosceles trapezium. And in the isosceles trapezium, your base angles are equal. So angle A will be equivalent to angle B. Angle C will be equivalent to angle D. Your diagonals AC will be equivalent to diagonal BD, and opposite angles, sum of the opposite angles will be your 180 degree. Obviously, because it is a quadrilateral, so sum of all the angles of a quadrilateral of your that is trapezium will be your 180 degree. That means angle A plus angle B plus angle C plus angle D will be your 360 degree for this condition also and for this condition also. For every quadrilateral, the sum of all the angles will be your 360 degree only. So this is about your trapezium. Now what parallelogram is? If both the pair of opposite sides is parallel to each other, then we say the quadrilateral to be parallelogram. Over here we can see AB is opposite to your CD. If AB is parallel to CD and BC is parallel to AD, then such type of quadrilaterals are known as parallelogram. Parallelogram is having very specific properties, like your opposite sides are equal. For parallelogram, opposite sides are equal, opposite angles are equal, opposite angles are equal, diagonals bisect each other, diagonals bisect each other, and diagonal, if we will be making any one diagonal, then it is going to divide the parallelogram into two congruent triangles. And if we are making only one diagonal, diagonal divides it in two congruent triangles. These are the properties of a parallelogram. So what all the properties of parallelogram is? What parallelogram is basically, if both the pair of opposite sides is parallel to each other, then we say the quadrilateral to be a parallelogram. Now in the parallelograms, opposite sides, that means AB will be equivalent to CD and BC will be equivalent to AD. Opposite angles will be equal, that means angle A will be equivalent to angle C and angle B will be equivalent to angle D. Diagonals will bisect each other. If we will be making the diagonals, it is going to bisect each other. The point where they will be intersecting each other will be the midpoint for both the two diagonals. If we will be making any one diagonal, then it will be dividing the parallelogram into two congruent triangles. Along with that, what we can see is sum of adjacent angles will be your 180 degree. Because if angle B is equivalent to angle D, and angle A is equivalent to angle C, so sum of the adjacent angles will be your 180 degree. All these are the properties of your parallelogram. Now there are some types of parallelograms are there. One is your rectangle, another is your rhombus, and third is your square. All these are your parallelograms. That means whatsoever the properties of parallelograms is there, all these properties will be followed by your rectangle also, rhombus also, and square also. And because all these are your quadrilaterals, so properties of quadrilaterals will even be followed by everyone. That means trapezium also, rectangle also, your parallelograms also, rhombus, square, kite, everyone will be following the properties of quadrilateral, and your rectangle, rhombus, and square will be following the properties of your parallelograms also. Now what rectangle is, what rhombus is, what square is? Rhombus is a special type of parallelogram in which your all the angles are 90 degree. Suppose A, B, C, D is a rectangle. So all the properties of parallelogram will be followed by your rectangle also. That means opposite sides will be parallel, opposite sides will be equal, opposite angles will be equal, diagonals will be bisecting each other, diagonal will be dividing it into two congruent triangles. All these properties will be followed by rectangle also, rhombus also, and square also. Except these properties, what all the properties rectangle follows. That is, your all angles are 90 degree. All angles of rectangle are your 90 degree. Along with that, in rectangle, diagonals are equal in measurement. Diagonals are equal. That means diagonal will be your AC and your BD. These will be the diagonals. That means AC will be equivalent to BD in the case of your rectangle. So these are the extra properties which a rectangle is following, except your parallelogram properties. All these properties it is following, except these two even are the properties which a rectangle is following. Now what rhombus is? Rhombus is again a type of parallelogram only, in which all the four sides are of equal measurement and all sides are equal. That means your AB will be equivalent to BC, will be equivalent to CD, will be equivalent to your AD. All the four sides of a rhombus are equal. Angles are not 90 degree as in the case of your rectangle, means, but over here all the four sides will be equal. Diagonals will even not be equal. So one of the property it is following is your all the four sides are equal. Another property is diagonals are perpendicular bisectors. That means the point at which they are intersecting. Suppose this is your diagonal BD, this is the diagonal AC, the point is O. So over here all these angles will be your 90 degree. Diagonals are perpendicular bisector. These angles, this angle, this angle, this angle, this angle will be your 90 degree. This is one of the property of your rhombus, that diagonals are perpendicular bisector. Along with that, diagonals bisect your interior angle also. Interior angles. That means this diagonal BD is bisecting your angle B also and angle D also. This diagonal AC will be bisecting angle A also and angle C also. This is even the property of a rhombus, that the diagonals bisect interior angle also. One more property is diagonals divide the rhombus in four congruent right angle triangle. That means these diagonals AC and BD is dividing this whole rhombus into four. This is 1, another 2, 3 and 4. Four congruent right angle triangle, because these angles are 90 degree. So all are your right angle triangle only, and these four triangles are congruent. So all these are the properties of your rhombus. Now let's see about square. Square is having all the four sides equal. A, B, C, D is a square. So for the square, all sides are equal. All sides are equal. All angles 90 degree. All the angles are 90 degree. Diagonals are equal. Diagonals are equal. That means AC will be equivalent to your BD. Diagonals will be your perpendicular bisector. That means these angles will be your 90 degree. Diagonals are perpendicular bisectors. Diagonals also bisect your interior angles. Diagonals bisect interior angles. That means diagonal AC will be bisecting angle A also, angle C also. Diagonal BD will be bisecting angle B also, angle D also. And again diagonals divide square in four congruent right angle triangle. Right angle triangle. So what so all the properties rectangle is following, what the properties rhombus is following, square is following all these properties. So square is having all the four sides equal, all angles will be 90 degree, diagonals will be equal, diagonals will be bisecting at 90 degree, they will be perpendicular bisectors, diagonals will be bisecting your interior angles also, and diagonals will be dividing the square into four congruent right angle triangles. All these are the properties of your square. Along with these properties, they are also following all the properties of a parallelogram also, because all these three are your parallelograms. Now let's see what kite is. In the kite, two pair of adjacent sides are equal. Over here, opposite sides are not equal. Two pair of adjacent sides are equal. AB will be equivalent to AD, BC will be equivalent to your CD. Here this O is the point where your both the diagonals are intersecting each other. They are not bisecting it, they are intersecting it each other. But diagonals are intersecting at 90 degree. That means these angles will be 90 degree. So diagonals intersect at 90 degree. They are perpendicularly bisecting each other, not bisecting, simply intersecting. These are not bisecting because AO is not equivalent to OC, although OB will be equivalent to your OD. Means larger diagonal is bisecting the smaller diagonal. Larger diagonal bisect smaller diagonal. That means a smaller diagonal is being bisected by the larger diagonal, means OB will be equivalent to your OD. This will be the property that OB will be equivalent to your OD. And if we are going to see, then this bigger diagonal AC is dividing this kite into two congruent triangles. The diagonal AC is dividing the whole kite into two congruent triangles. So larger diagonal divides the kite in two congruent triangles. That means same triangles. Now along with that, these larger diagonal will be bisecting angle A also, angle C also. This diagonal AC is bisecting angle A and angle C. Larger diagonal bisects interior angles. That means your angle A will be bisected and angle C will be bisected by your this diagonal. Along with that, if we are going to see, your angle B will be equivalent to angle D. That means this angle A, where your non-equal adjacent sides are meeting, angle B will be equivalent to angle D. All these are the properties of your kite. Now from here, if we are going to see, then we can say that all the parallelograms are trapezium, because for trapezium only one pair of opposite sides should be equal, and in the case of parallelogram we are having both the pair of opposite sides parallel. That's the reason we can say that all the parallelograms are your trapezium, because for trapezium only one pair of opposite sides should be parallel to each other, but here we are having both the pair of opposite sides parallel. But your trapeziums are not your parallelogram, because for a trapezium to be a parallelogram, both the pair of opposite sides should be parallel, but here we are having only one pair of opposite side parallel. So we can say all the parallelograms are your trapezium, but trapeziums are not your parallelogram. Similarly, we can say all the squares are your rectangle also, and they are your rhombus also, because for rectangle, if any one of the angle of any of the parallelogram is 90 degree, if in a parallelogram any one angle is 90 degree, then we say that parallelogram to be a rectangle. And over here, so we are having all the four angles 90 degree. So we can say, and diagonals even should be equal. Here in the case of a square, both the diagonals are equal. So all the squares are your rectangle, but all the rectangles are not square, because for a rectangle to be a square, all the four sides should be equal, but in rectangle we are not having all the four sides equal. So rectangles are not square, but squares are your rectangle. Similarly, all the squares are your rhombus also, but all the rhombus are not your square, right? Similarly, we can say that kite is not a parallelogram and your trapezium is even not a parallelogram. So this is what we can conclude from all this discussion. Hope it is clear what all the properties of your trapezium is, rectangle is, parallelogram is, rhombus, square, kite. All these are your quadrilaterals. Three types of quadrilaterals we have: trapezium, parallelogram, and kite. Under the category of parallelogram, we are having three more cases, that is your rectangle, rhombus, and square. So we have discussed all these properties. Just now we have discussed the various properties of various quadrilaterals like your trapezium, parallelograms, and kite. So now let's discuss how we can prove the various properties of a parallelogram. So various properties of parallelogram. First of all, theorem 8.1. A diagonal of a parallelogram divides it into two congruent triangles. As just now we have discussed that if ABCD is a parallelogram, then both the pair of opposite sides will be parallel to each other. That means your AB will be parallel to CD and BC will be parallel to your AD. We have to prove that the diagonal AC is dividing this parallelogram into two congruent triangles. So what given to us is that ABCD is a parallelogram, it is given to us, and we have to prove that triangle ABC is congruent to triangle CDA. These two triangles are congruent, this we have to prove. Now let's see how we can prove it. So we will be considering these two triangles ABC and CDA. These two triangles we will be considering. As just now we said, because it is a parallelogram, both the pair of opposite sides will be parallel. So now BC is parallel to your AD. So this is making your Z. So angle 2 will be equivalent to angle 4 because they are alternative interior angles. Because BC is parallel to AD, and if we are going to see, it is forming a Z. That means angle 2 and angle 4 both are your alternative interior angles and they will be equal. So we have written angle BCA, that means your angle 2, this is your angle 2, is equivalent to CAD angle 4. They will be equal because the lines are parallel. BC is parallel to AD and they are your alternative interior angles. Similarly, we know that AB is parallel to your CD, and if these two lines are parallel, then again angle 1 and angle 3 both are your alternative interior angles. AB is parallel to CD, so your angle BAC, that is angle 1, will be equivalent to DCA, that is your angle 3, because they are alternative interior angles. Similarly, in these two triangles, AC is common for both the two triangles. So AC is common. So we can say by ASA congruency, both the two triangles will be congruent. So this is how, by using the concept of congruency, we can prove that these two triangles are your congruent. Now let's understand some more properties of a parallelogram. Theorem 8.2. In a parallelogram, opposite sides are equal. That means it is given to us that a quadrilateral is there which is a parallelogram, and in this parallelogram your opposite sides will be equal. So it is given ABCD is a parallelogram and we have to prove that the opposite sides AB is equivalent to CD and BC is equivalent to AD. Now if ABCD is a parallelogram, then both the pair of opposite sides will be parallel to each other. That means AB will be parallel to CD and BC will be parallel to your AD. Now given to us is that ABCD is a parallelogram, that means opposite sides are parallel. We have to prove that AB is equivalent to CD and BC is equivalent to AD. This we need to prove. Now what we will be doing is we will be constructing a diagonal AC. So we have drawn a diagonal AC, we have drawn. For proving it, what we'll be doing is we'll be considering these two triangles as just now we have done in theorem 8.1 also. Similarly, we'll be considering these two triangles. So triangle ABC and triangle CDA. These two triangles we'll be considering. In the triangle ADC, angle 1, and in the triangle CDA, angle 3. These angle 1 and angle 3 are your alternative interior angles, because see, AB is parallel to your CD. So if AB is parallel to CD, these are making a Z. So angle 1 and angle 3 are making alternative interior angle. So these two angles will be equal. So angle 1 is equivalent to angle 3. Similarly, we know that BC is parallel to your AD. If BC is parallel to AD, then your angle 2 will be equivalent to your angle 4. This angle 2 will be equivalent to angle 4, as again they are making a Z. So these two are your angle 2 and angle 4 are your alternative interior angles. That's the reason these two angles will even be equal. Now in these two triangles, AC is common for both the two triangles. So AC will be equivalent to your AC because it is common for both the two triangles. Now in these two triangles, we can say that by ASA, these two triangles will be congruent to each other. By ASA congruency rule, these two triangles will be congruent. And we know that if we have proved that the triangles are congruent, then their corresponding parts will be equal. So by CPCT, we can say that AB will be equivalent to your CD and your BC will be equivalent to your AD. So we can see AB and CD, they are your opposite sides of the parallelogram, and BC and AD are even the opposite sides of the parallelogram. And this was to be proved, so hence proved. This is how we can prove that in a parallelogram opposite sides are equal. Now let's see the another theorem, theorem 8.3. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So here it is given to us that it is a quadrilateral. It is not a parallelogram. It is not given. Simply it is given that in any quadrilateral, if opposite sides are equal, that means ABCD is a quadrilateral. It is not given that it is a parallelogram. We have to prove that it will be a parallelogram. Only given to us is that the opposite sides are equal. That means AB is equivalent to CD and BC is equivalent to AD. It is given to us, and we need to prove that ABCD is a parallelogram. So given to us is that ABCD is a quadrilateral and AD is equivalent to your BC. Opposite sides are equal, and AB is equivalent to CD. It is even equal. It is given to us. We need to prove that ABCD is a parallelogram. This we need to prove. Again, what we will be doing is we will be making a diagonal AC, and then we will be considering these two triangles. One will be your ABC, another will be your CDA. These two triangles we will be considering. In these two triangles, it is given to us that AB is equivalent to CD. AB is equivalent to CD, it is given to us. Along with that, of triangle ABC, BC is equivalent to AD. This is even equal, it is even given to us. And in these two triangles, AC is common. So AC is equivalent to AC, it is common. So we can say that these two triangles are congruent by your SSS congruency. Because this was equivalent to this, BC was equivalent to AD, and AC is common. So these two triangles ABC will be congruent to your CDA by SSS congruency. Now if they will be congruent, then their corresponding angles will even be equal. That means your angle 1 will be equivalent to angle 2. The corresponding angle of 1 is your angle 2. So angle 1 will be equivalent to angle 2 and angle 3 will be equivalent to angle 4 by CPCT. Because these two triangles are congruent, just now we have proved. So by CPCT we can say that angle 1 will be equivalent to angle 2 and angle 3 will be equivalent to angle 4. Now if these are equal, so we can see over here that angle 1 and angle 2 are forming alternative angle. Alternative interior angles they are forming, and we know that if alternative interior angles are equal, then the lines are parallel. So over here what we can see is angle 1 is equivalent to angle 3 by CPCT we had concluded. Angle 3 is equivalent to angle 4 just by CPCT we have concluded. And angle 1 and angle 2 are alternative interior angles for the line AB and CD. If AB and CD are the lines and AC is the transversal, then angle 1 and angle 2 are alternative interior angles. Similarly, if BC and AD are the lines and AC is the transversal, then angle 3 and angle 4 are your alternative interior angles. So we have seen that both the pair of alternative interior angles are equal. So we can conclude that the lines will be parallel. That means AB will be parallel to CD and BC will be parallel to AD. And if both the pair of opposite sides are parallel in any of the quadrilateral, we know that it is a parallelogram. So we can say that ABCD is a parallelogram. So this is how we can prove these type of theorems. Let's understand some more properties of a parallelogram. Theorem 8.4. In a parallelogram, opposite angles are equal. Just now we had proved that in a parallelogram, opposite sides were equal. Now we have to prove that in a parallelogram, opposite angles are even equal. So it is given to us that ABCD is a parallelogram. And if it is a parallelogram, then both the pair of opposite sides will be parallel to each other. That means AB will be parallel to CD and BC will be parallel to your AD. And we have to prove that angle A is equivalent to angle C and angle B is equivalent to angle D. That means opposite angles are equal. So given to us is that ABCD is a parallelogram. We have to prove angle A equivalent to angle C and angle B equivalent to angle D. Now what we will be doing is we will be constructing a diagonal AC, then in proving because ABCD is a parallelogram, that means AB is parallel to your CD and your BC is parallel to your AD. Just now we had seen that if these two are parallels and AC is the transversal, so angle 1 will be equivalent to angle 3 because they are alternative interior angles. So angle 1 will be equivalent to angle 3 because they are alternative interior angles. Suppose this is your equation 1. Now because BC is parallel to AD and your AC is the transversal, so angle 2 and angle 4, they are even alternative interior angles, so they will even be equal. So angle 4 will be equivalent to your angle 2 because they are alternative interior angles. This is equation number 2. Now if we will add equation number 1 and equation number 2, we will be getting angle 1 plus angle 4 equivalent to angle 2 plus angle 3. Because if in equals, we will be adding equals, we will be getting equal only. In the Euclid chapter, we had learned it that if in equals, we are adding equals, the result will even be a equal. So if we will be adding angle 1 and angle 4, we will be getting angle A. This angle A is addition of your sum of angle 1 and angle 4. So angle 1 plus angle 4 could be written as angle A. Similarly, angle 2 plus angle 3 could be written as angle C. So angle A equivalent to angle C, which are opposite angle and which was to be proved. Similarly, we need to prove that angle B is equivalent to angle D. What we could do for this is we can draw the diagonal BD. And now in these two triangles, we will be considering BCD and your DAB. In these two triangles, we will be considering your this angle 5 will be equivalent to angle 6 and angle 7 will be equivalent to your angle 8. Now angle 5 is equivalent to angle 6 and angle 7 is equivalent to angle 8. Again, if you will be adding it, it will be your angle 5 plus angle 7 equivalent to angle 6 plus angle 8. Angle 5 plus 7 is your angle D and angle 6 plus angle 8 is your angle B. So this is how you can prove that the opposite angles of a parallelogram are equal. This is the proof of it. Now let's see the other theorem. Theorem 8.5. If in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. It is given that ABCD is any quadrilateral and opposite angles are equal. That means angle A is equivalent to angle C and angle B is equivalent to angle D. It is given to us. We need to prove that ABCD is a parallelogram. So what we will be doing is given to us is that ABCD is a quadrilateral. It is given angle A equivalent to angle C and angle B equivalent to angle D. It is also given to us. We need to prove that ABCD is a parallelogram. So how we will be proving it? So sum of all the angles of a quadrilateral is 360 degree. We have just now seen the angle sum property of a quadrilateral, that sum of all the four angles of a quadrilateral is your 360 degree. So angle A plus angle B plus angle C plus angle D will be your 360 degree. Now just now it is said that angle A is equivalent to angle C. So instead of angle C, we can write angle A. So instead of angle C, we have written angle A. This angle A we have written as it is. Instead of this angle C, we have written angle A. Now angle B we have written. And now because angle B is equivalent to angle D, so instead of angle D, we have written angle B. So instead of angle D, we have written angle B. It is equivalent to your 360 degrees. Now 2 times of angle A plus 2 times of angle B is 360 degree. So we can say angle A plus angle B will be 360 divided by 2. That is your 180 degree. That means angle A plus angle B is 180 degree. This we have proved. Now if we are going to see the line BC and your AD, if your AB is the transversal, then they are co-interior angles or the angles on the same side of the transversal. And if the sum of co-interior angle is coming equivalent to 180 degree, then we say that the lines are parallel. Over here we can see BC and AD are the lines and AB is the transversal. So your angle B and angle A are the interior angles on the same side of the transversal. That means they are co-interior angles. And sum of co-interior angles is 180 degree. Just now we have proved. And we know when the sum of co-interior angles is 180 degree, then the lines are parallel. So BC will be parallel to your AD. Similarly, we can prove that AB is parallel to your CD also. How we can do that? Instead of replacing your C by A and D by B, we can replace this in terms of your A and B also. Now see, angle A could be written as angle C also. Instead of angle A, what we can write? Angle C. Instead of angle B, what we can write? Angle D. So plus angle D. This is angle C. This is angle D. It is equivalent to 360 degrees. That means 2 times of angle C plus angle D is your 360 degrees. That means angle C plus angle D is 180 degrees. 360 divided by 2 will be your 180 degree. Now angle C plus angle D, it is your 180 degree. Just now we have proved. So we can say that the lines, opposite lines will even be your parallel to each other. Similarly, we can say, means if we have, once we have proved your AD is parallel to your BC, secondly we can prove that your AB is parallel to your CD. And once both the pair of opposite sides is parallel to each other in any of the quadrilateral, we can say that the quadrilateral will be a parallelogram. So once we had already proved that BC is parallel to AD, similarly we can prove your AB is parallel to your CD. If we have proved like this, we can take it as your A and D also. Like what we could do is, here from this, so we can conclude that your BC is parallel to AD only. Now if instead of it, I am keeping angle A as angle A, angle B, instead of angle B, I am writing angle D. Angle C, instead of angle C, I am writing angle A, and angle D, I am keeping it as it is. It is your 360 degrees. So 2 times of angle A plus angle D will be your 360 degrees, or we can say angle A plus angle D is your 360 divided by 2, that is your 180 degrees. So if angle A plus angle D, that means angle A plus angle D is 180 degree. So what it means is, if AB is the line and CD is the line and AD is the transversal, in that case A and D are your co-interior angles on the same side of the transversal. That means if the interior angles on the same side of the transversal sum is your 180 degree, then the lines will be parallel. That means AB will be parallel to your CD. So this is how we can prove both the pair of opposite sides in a quadrilateral to be parallel, and if it is parallel, so it will be a parallelogram. Just now we have proved that AD is parallel to your BC, and now we have proved AB is parallel to your CD. Now this is parallel to this is parallel to this, we have proved. So ABCD is a parallelogram. So this is how we can prove the theorems. Let's understand some more properties of a parallelogram. Theorem 8.6. The diagonals of a parallelogram bisect each other. That means if ABCD is a parallelogram, then the diagonals AC and BD, if they are going to intersect at point A, then this is the midpoint of your AC also and BD also. That means what is given to us is ABCD is a parallelogram, it is given. That means your AB is parallel to CD and BC is parallel to AD. It is given to us. We have to prove that OA is equivalent to OC. That means O is the midpoint of AC and O is the midpoint of BD also. That means OB is equivalent to OD. This we need to prove. So what we will be doing is, we will be taking triangle AOB. This triangle we will be taking, and another triangle we will be taking COD. These two triangles we will be considering. In these two triangles, we can see angle 1, this angle at O, this angle 1 is equivalent to angle 2 because they are vertically opposite angle. This angle 1 of triangle AOB is equivalent to angle 2 of triangle COD because they are your vertically opposite angle. This AB is equivalent to CD because ABCD is a parallelogram. So if ABCD is a parallelogram, opposite sides will be equal. Just now we have proved. So AB will be equivalent to CD. This we can take because opposite sides of a parallelogram are equal. Then again, because AB is parallel to CD and AC is the transversal, so angle 3 will be equivalent to angle 4. They are alternative interior angle. So angle 3 will be equivalent to angle 4 as they are your alternative interior angle. So we can say by AAS congruency, both the two triangles will be congruent. By AAS congruency, both the two triangles are your congruent. And if the triangles are congruent, we can say the corresponding parts will be equal. So by CPCT, OA will be equivalent to OC and your OB will be equivalent to your OD. So by proving that the triangles are congruent, we can conclude that by CPCT their corresponding parts will be equal. That's the reason your OA will be equivalent to OC and OB will be equivalent to your OD. And this was to be proved that O is the midpoint of AC and O is the midpoint of your BD. So this is how we can prove it. Now let's see the another theorem, that is theorem 8.7. If diagonals of a quadrilateral bisect each other, then it is a parallelogram. That means it is simply a quadrilateral and O is bisecting your AC also and BD also. It is given to us. That means it is given that OA is equivalent to OC and OB is equivalent to OD. It is given to us. We have to prove that ABCD is a parallelogram. So what is given to us is that ABCD is a quadrilateral and OA is equivalent to OC and OB is equivalent to OD. It is given to us. We have to prove that ABCD is a parallelogram. So how we can prove it? We will be taking the triangle AOB and triangle COD. These two triangles we will be considering. In these two triangles, this angle 1 of triangle AOB will be equivalent to angle 2, that is of triangle COD, because they are your vertically opposite angles. So angle 1 will be equivalent to angle 2, they are vertically opposite angle. The OA of this triangle is equivalent to OC of this triangle because it is already given to us that O is the midpoint of AC. So OA is equivalent to OC given to us. OB is equivalent to OD. It is also given to us. So in these two triangles, this side is equivalent to this side is equivalent to this side, and included angle is equal because they are vertically opposite angle. So by SAS congruency, the two triangles will be congruent. So we can say the triangle AOB is congruent to triangle COD by your SAS congruency rule. Now, if the triangles are congruent, so what we can say by CPCT, this angle 3 will be equivalent to angle 4. They are the corresponding angles. Angle 3 will be equivalent to angle 4 and angle 5 will be equivalent to angle 6. This we can conclude by CPCT because we have proved these triangles to be congruent. And if we are going to see this angle 3 and angle 4, they are alternative interior angles if AB and CD are the lines and AC is the transversal. So angle 3 and angle 4 is your alternative interior angle. And we know that if alternative interior angles are equal, lines are parallel. So we can say that AB will be parallel to your CD. So from here we can say because alternative interior angles are equal, so AB will be parallel to your CD. Similarly, we will be considering your triangle BOC. This triangle BOC we will be considering and triangle DAO will be considering. Then we can prove that BC will be parallel to your AD also. How we can do that? See, in this triangle, first of all, we will be considering this triangle BOC and triangle will be taking DOA. In these two triangles, your OB is equivalent to OD. It is given to us. Similarly, OC of this triangle is equivalent to OA of this triangle. And suppose this is your angle, say 7. This is your angle 8. So angle 7 is equivalent to angle 8 because they are vertically opposite angle. So these two triangles are congruent by your SAS congruency. These two triangles are congruent. And if these two triangles are congruent, your this angle, suppose this is your angle 9 and this angle, this is your angle 10. So these angles, they are the corresponding angles, they will be equal. And if these angles will be equal, and if we are going to consider the line BC and AD, and BD as the transversal, then they are alternative interior angles. And if alternative interior angles are equal, we say lines to be parallel. So this is how we can prove that BC will be parallel to your AD. Already we had proved that AB is parallel to CD. Now we have proved your BC is parallel to your AD. So if both the pair of opposite sides are parallel in any of the quadrilateral, it is your parallelogram. So this is how we can say that both the pair of opposite sides are parallel. That's the reason ABCD will be a parallelogram. So this is how we can prove all these types of theorem. Till now we have seen that in a parallelogram, opposite sides are equal, opposite angles are equal, and the diagonals bisect each other. Along with that, if any of the quadrilateral is given to us in which opposite sides are equal, then we say that the quadrilateral is a parallelogram. Similarly, if in any of the quadrilateral opposite angles are equal, then we say it to be a parallelogram. And if in any of the quadrilateral diagonals bisect each other, then also we say the quadrilateral to be a parallelogram. Now let's discuss some other properties or some other conditions for a quadrilateral to be a parallelogram. So theorem 8.8 says a quadrilateral is a parallelogram if a pair of opposite side is equal and parallel. Instead of both the pair of opposite sides, if only one pair of opposite side is equal also and parallel also, then a quadrilateral will be a parallelogram. How we can prove it? Just see it. Given to us is that ABCD is a quadrilateral. It is given to us in which one pair of opposite side, that is AB, is equivalent to CD also, and AB is parallel to CD also. That means AB is equivalent to CD and AB is parallel to your CD. It is already given to us. We have to prove that ABCD is a parallelogram. This we need to prove. So what we will be doing is, we will be joining A and C, and then we will be considering the triangle ABC and triangle CDA. These two triangles we will be considering. In these two triangles, AB of triangle your ABC is equivalent to CD of triangle your CDA. So AB is equivalent to CD. It is already given to us in the question. AC is common for both the two triangles. In the triangle ABC also AC is coming. In the triangle CDA also AC is coming. So AC is common for both the two triangles. Now in these two triangles, it is given that AB is parallel to your CD. It is given to us, and AC is the transversal. So if these two are the parallel lines and this is the transversal, so angle 1 will be the alternative interior angle for angle 2. Angle 1 and angle 2 will be your alternative interior angle. That's the reason angle 1 will be equivalent to your angle 2. So we can say that by S congruency rule, these two triangles will be congruent. And if the triangles are congruent, by CPCT, we can conclude that the corresponding parts will even be equal. Just now we have proved that the triangle ABC is congruent to triangle CDA. Now if these are congruent, then their corresponding part, that means BC, will be equivalent to your AD also. In this quadrilateral, already AB was equivalent to your CD. And just now by CPCT, we have proved that BC is also equivalent to your AD. And we know that in any of the quadrilateral, if both the pair of opposite sides are equal, we say it to be a parallelogram. Now we have proved that both the pair of opposite sides are equal. That's the reason ABCD will be a parallelogram. This is how we can prove it. Now let's see some of the questions from your exercise 8.1. So exercise 8.1, question number 2 we are considering. Question number 2. If the diagonals of a parallelogram are equal, then show that it is a rectangle. So diagonals of a parallelogram given to us is that this is a parallelogram. A, B, C, D is a parallelogram in which diagonal AC is equivalent to diagonal BD. It is given to us. We need to prove that ABCD is a rectangle. So what is given to us is given that ABCD is a parallelogram. It is given. That means what all the properties of parallelogram are there, ABCD is going to follow it. That means opposite sides will be parallel also, both the pair of opposite sides will be equal also, opposite angles will be equal, and diagonals are even going to bisect each other. So all the properties of parallelogram will be followed by your ABCD. Along with that, it is even given that AC, diagonal AC is equivalent to diagonal BD. It is also given to us. We need to prove that ABCD is a rectangle. This we need to prove. So what we will be doing is, we will be considering the triangle ADC and triangle your BCD. These two triangles we will be considering. This is one of the triangle and this is your another triangle. So in triangle, in the proof, considering in triangle ADC and triangle BCD. In these two triangles, AD is equivalent to BC. AD is equivalent to BC because they are the opposite sides of a parallelogram. Reason being, they are opposite sides of a parallelogram. That's the reason AD will be equivalent to your BC. DC is common in both the two triangles because it is your common, so it will be equal. In the triangle ADC also, DC is coming. In the triangle BCD also, your DC is coming. And in the triangle ADC, your diagonal AC is equivalent to in the triangle BCD, your diagonal BD, because it is given to us in the question that the diagonals are equal. That's the reason they both will be equal. Now we can see by SSS congruency, we can say that triangle ADC will be congruent to triangle BCD. These two triangles will be congruent, and if triangles will be congruent, their corresponding parts will be equal. Now see over here, in triangle ADC, this angle D will be equivalent to in the triangle BCD. C means corresponding to this angle D, the corresponding angle is your corresponding angle will be your C. That means angle D, this whole angle D will be equivalent to your angle C. And we know that the sum of the adjacent angles in a parallelogram is your 180 degree. That means angle C plus angle D will be your 180 degree because ABCD is a parallelogram, and in a parallelogram sum of adjacent angles is your 180 degree. Now because angle C and angle D both are equal, so we can replace angle D by angle C also, or we can replace angle C by angle D also. So we can write angle C plus angle C is 180 degree, or we can say 2 times of angle C is 180 degree, or we can say angle C is your 90 degree. And we know that a parallelogram will be a rectangle if we can prove that any of the 4 angles is your 90 degree. Just now we have proved angle C is 90 degree. So we can say that ABCD, which is already a parallelogram, will be a rectangle. Now see how we can say angle C if C is 90, and because it is a parallelogram, so if it is a parallelogram, opposite angle will even be equal, so angle A will even be 90. Just now we have said angle C and angle D both are equal. So if angle C is 90, so angle D will also be 90. And if angle D is 90, then opposite angle B will also be 90. So if we are proving that if any one angle of a parallelogram is 90 degree, it will be a rectangle. So this is how we can prove it. Now let's see question number, say 10. Question number 10. ABCD is a parallelogram. The figure, first of all, I am making the figure. This is your A, B, C, D. This is the diagonal BD. From here, an altitude that is at point P. And from here, it is your point Q. It is even your 90 degree. So ABCD is a parallelogram. Given to us is ABCD is a parallelogram, and AP and CQ are perpendiculars from vertices A and C on diagonals BD. So this is 90 degree, this is 90 degree, it is given to us. We have to show that to prove triangle APB is congruent to triangle CQD. This we need to prove. This is the first part, and the second part is AP is equivalent to CQ. This we need to prove. So over here it is given that ABCD is a parallelogram. If it is a parallelogram, opposite sides will be equal. So this side will be equal to this side and this side will be equivalent to this side. Opposite sides will be your parallel also. Opposite angles will be parallel also. So we have to prove that the triangle APB, this triangle is congruent to your CQD, CQD. Now we are considering these two triangles. In triangle APB and triangle CQD. In these two triangles, if we are going to see, AB is equivalent to CD because they are opposite sides of parallelogram. Opposite sides of parallelogram. That's the reason AB of triangle ABP is equivalent to CD of triangle CDQ. Over here, angle APB is equivalent to angle CQD. CQD. It is your 90 degree. It is already given to us. Both are 90 degree. It is given to us. And because it is a parallelogram, so AB will be parallel to CD also. And that's the reason this is suppose angle 1 and this is your angle 2. So angle 1 will be equivalent to angle 2 because they are alternative angle. Angle 1, that is your angle CDQ. We can write it as angle C. First of all, we have considering this. So we will be taking ABP. ABP is equivalent to angle CDQ. They are alternative angle. Alternative interior angles. That's the reason both of them will be equal because it is a parallelogram, so opposite sides are equal. So this angle and this angle will be your alternative interior angle. Now we can see in these two triangles by your AAS congruency, these two triangles are congruent. So by AAS congruency, we can say that triangle APB is congruent to triangle your CQD. So first part is proved. Now if the triangles are congruent, we can say that by CP/CT their corresponding parts will be equal. So we have to prove AP is equivalent to CQ. So AP corresponds to your CQ only. So we can say that by CP/CT your AP will be equivalent to your CQ. Hence proved. So this is how we can solve the questions. Now let's understand one of the most important theorem of the chapter, that is midpoint theorem. So what midpoint theorem says, the line segment joining the midpoints of two sides of a triangle is parallel to the third side and half of it. That means if there is a triangle ABC in which E is the midpoint of AB and F is the midpoint of AC, then EF will be parallel to BC and EF will be half of BC. The line segment joining the midpoints of two sides of a triangle. These are the two sides of the triangle. These are the midpoints of these two sides of a triangle. If we are joining these line EF, this line segment, will be parallel to the third side. So EF will be parallel to the third side BC and it will be half of it. That means EF will be half of your BC. This is your midpoint theorem. Now how we can prove it? So given to us is your triangle ABC is there, it is given to us. E is the midpoint of AB, that means AE is equivalent to EB, it is given to us. F is the midpoint of AC, that means AF is equivalent to FC, it is given to us. We have to prove that EF is parallel to BC and EF is half of BC. EF is parallel to BC and EF is half of BC, this we need to prove. For that, what construction we will be doing? From the point C, we will be making a line CD which will be parallel to your AB. A line CD we will be drawing which will be parallel to your AB and we will be extending this EF till the point where it is going to intersect it. And this point will be your point D. So what construction we have done? We have drawn CD which is parallel to your AB. This AB is parallel to your CD by construction and we have extended this EF till the point where it is intersecting this line and this point is your D. Now how we will be proving it? This is the construction we had done. Now we will be considering these two triangles. We will be considering A EFE, this triangle, and CFD. These two triangles we will be considering. In these two triangles, angle 1, this angle 1 will be equivalent to angle 2 because they are vertically opposite angle. This angle 1, that is your angle AFE, will be equivalent to your DFC, which is angle 2. So angle 1 will be equivalent to angle 2 because they are vertically opposite angle. Now because F is the midpoint of your AC, that's the reason AF of triangle AFE is equivalent to FC of triangle CFD. So in these two triangles, AF of this triangle is equivalent to CF of this triangle because F is the midpoint of your AC. So AF is equivalent to FC because F is the midpoint of AC. Now by construction we have taken AB is parallel to your CD. This is by construction we have taken. So if AB is parallel to CD and your AC is the transversal, so angle 3 and angle 4 are alternative interior angles. So angle 3 will be equivalent to angle 4 because they are alternative interior angle. So angle your FAE angle 3 is equivalent to your FCD angle 4 because they are your alternative interior angles. So in these two triangles, this angle is equivalent to this angle 1 is equivalent to angle 2 and AF is equivalent to your FC. So by ASA congruency, both the two triangles will be congruent. ASA. So we can say that by ASA congruency, both the two triangles will be congruent. And if these two triangles are congruent, what we can interpret from CPCT? We can say that the corresponding parts will even be equal. And if corresponding parts will be equal, we can say EF, this EF will be equivalent to your FD. That means your EF will be equivalent to your FD. This side will be equivalent to your this side. EF will be equivalent to your FD. These are the corresponding parts. Along with that, AE will be equivalent to your CD. This AE is equivalent to your CD, this part. AE will be equivalent to CD. This we can conclude by your CPCT. So by CPCT we have concluded that EF is equivalent to FD and your AE will be equivalent to your DC. This we have concluded. Now we know that E is the midpoint of your AB. That means AE is already equivalent to your EB. It was already given to us that E is the midpoint. That means AE is equivalent to EB. It was already given to us. And just now we have proved that AE is equivalent to your DC. So what we can say is that DC is also equivalent to your EB. This side AE is equivalent to EB is equivalent to DC. This we can prove it because just now we have said that AE is equivalent to EB. AE is equivalent to EB because E was the midpoint and we have proved that AE is equivalent to CD. So this CD will be equivalent to your EB, right? And by construction we have taken AB parallel to your CD. So if AB is parallel to CD, so we can say BE is parallel to your CD, right? So we have proved that CD is equivalent to BE also and CD is parallel to BE also. And if in any of the quadrilateral, one pair of opposite side is equal also and parallel also, then we say that the quadrilateral is a parallelogram. That's the reason BCDE, which was a quadrilateral, is a parallelogram because one pair of opposite side, that is CD and BE, are equal also and are parallel also. That's the reason this BCDE is a parallelogram. And if this is a parallelogram, then opposite sides will be equal also and opposite sides will be parallel also. So we can say BC is equivalent to your ED and BC is parallel to your ED. Opposite sides BC will be parallel to ED also and they will be parallel along with that equal also. So what we can conclude is BC is parallel to ED and BC is equivalent to ED. Now, if BC is parallel to ED, that means BC is parallel to EF also. If BC is parallel to ED, so EF is a part of it only. So BC will be parallel to your EF. BC is parallel to EF. One of the part is solved, that this EF is parallel to BC. This part is done. Now because ED is equivalent to your BC. And we have proved that EF is equivalent to your FD because these two triangles were congruent. So we have proved that EF is equivalent to FD. That means instead of EF is your half of your ED also. EF is half of your ED. So what we can say is BC is equivalent to ED. This BC was equivalent to your ED, and BC is ED could be written as 2 times of your EF. EF plus EF. This is even your equivalent. This EF is equivalent to your FD. So this ED could be written as EF plus EF. That means BC is equivalent to 2 times of EF, or we can say EF is half of your BC. This was only to be proved that EF is parallel to BC and EF is half of your BC. This is how we can prove it. What we have done is we have taken the triangle in which E was the midpoint of AB and F was the midpoint of AC. We have joined these two. We have to prove that this line EF is parallel to the third side BC and it is half of the third side BC. Now what we have done is from C we have drawn a line parallel to your AB. This is a line and we have extended this wheresoever it is intersecting. This point is your D. Now we are considering these two triangles. In these two triangles, these angles are vertically opposite angle. This F is the midpoint of AC. That's the reason AF will be equivalent to FC. And because these two lines are parallel by construction, so angle 3 will be equivalent to angle 4. They are alternative interior angle. Now, these two triangles are congruent by ASA. If these two triangles are congruent by CPCT, we can say that their corresponding parts will be equal. That means EF will be equivalent to your FD. EF will be equivalent to FD and your AE will be equivalent to your DC. But E was the midpoint of AB, so AE will also be equivalent to EB. And just now we have said that AE is equivalent to your DC. That means DC is equivalent to your EB also and AE also. And if these two are equal, by construction we have taken these two parallel. So this is parallel to this also and this is equivalent to this also. That's the reason if one pair of opposite sides are equal and parallel, we say a quadrilateral to be a parallelogram. So it will be a parallelogram. Now, if it is a parallelogram, so opposite sides will be equal also and parallel also. So BC will be equivalent to your ED because it is a parallelogram. So it will be equivalent to your ED and BC will be parallel to ED. Now BC is parallel to ED means BC is parallel to your EF also. Now BC is equivalent to your ED and EF is equivalent to your FD. So BC, ED could be written as your EF plus FD. Now FD is equivalent to EF. So BC is equivalent to EF plus EF. Yani BC is equivalent to 2 times of EF. So BC is 2 times of EF. We can say that EF is half of your BC. That was only to be proved that this EF is parallel to BC and EF is half of BC. This is how we can prove it. It is very important theorem from this chapter. Now let's understand converse of midpoint theorem. Theorem 8.10, that is the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. That means it is given to us that if there is a triangle ABC in which E is the midpoint of AB and EF is parallel to BC, in that case F will be the midpoint of AC also. That means AF will be equivalent to your FC. The line drawn through the midpoint of one side of a triangle. This is the one side of a triangle. Line drawn from the midpoint of it, that is E is the midpoint of it, parallel to another side. This line EF is parallel to your another side BC. Then it bisects the third side. Then this EF is going to bisect the third side, your AC. That means F will be the midpoint of your AC. So given to us is triangle ABC is there. AE is equivalent to EB and EF is parallel to BC. It is given to us. We have to prove that F is the midpoint of AC. Now what we will be doing is, how we will be proving it? We are assuming that F is not the midpoint of your AC. If F is not the midpoint of AC, in that case there will be any other point which will be the midpoint of AC. So we are assuming that D is the point which is midpoint of AC. Now if D is the midpoint, we have joined your ED. We have joined your ED. So by construction, D is the midpoint of your AC. We have assumed that F is not the midpoint of AC. So we have taken D a point which is the midpoint of AC, and we have joined your ED. So let us assume that F is not the midpoint of AC and D is the midpoint of AC. Now in the triangle ABC, F is the midpoint of AB. It is already given to us. By construction, your D is the midpoint of your AC. So by midpoint theorem, what we can say is, if there are two sides of a triangle in which we will be taking the midpoints and we are going to join the midpoints, then the line will be parallel to your third line. That means ED will be parallel to your BC according to your midpoint theorem if D is the midpoint of AC. So according to it, your ED will be parallel to your BC. But it is given to us that EF is parallel to BC. By construction, your ED should be parallel to your BC, but it is given to us that EF is parallel to your BC. It is not at all possible. Why it is not possible? Let's see, BC and BC both are same. So BC, from both of them, from this equation 1 and from this equation 2, we will be saying that BC is parallel to your ED is parallel to your EF. Now ED and EF cannot be parallel to each other because they are originating from the same point E only. From the same point, if two lines are originating, this is your E, this is your D, and this is your F. So they can never ever be parallel to each other. So why this contradiction is arising? This contradiction is arising because of our wrong assumption. So whatsoever our assumption was that D is the midpoint and F is not the midpoint was actually wrong. Actually, F is only the midpoint of your AC, and this was only to be proved. So this is by contradictory statement, we will be proving it that F is actually the midpoint of your side AC also. Now let's see some of the questions from your exercise 8.2. Say question number 4. I'm just removing this part. Question number 4 says ABCD is a trapezium. First of all, I'm making the figure. It is given to you in the question. A, B, C, D, and this is the diagonal, this is the side, this point is your E and this point is your F. ABCD is a trapezium in which AB is parallel to DC. Given to us is AB is parallel to your DC. BD is a diagonal and E is the midpoint of AD. E is midpoint of AD. A line is drawn through E parallel to AB. That means EF is parallel to AB. It is also given to us. Intersecting BC at F, show that F is the midpoint of BC. We have to prove that this point F is the midpoint of your BC. It is already given that AB is parallel to CD and your EF is also parallel to your AB. That means AB is parallel to your EF also and is parallel to your DC also. These three lines are parallel to each other. It is given to us. Now E is the midpoint. That means your ED will be equivalent to your EA. Now if we are going to consider the triangle in triangle DAB. In this triangle DAB, E is the midpoint of your DA and E, suppose this point is your O. If AB is parallel to EF, then AB will be parallel to your OE also, right? So in triangle DAB, your E is the midpoint of your AD and OE is parallel to your AB. So by converse of your midpoint theorem, the line drawn through the midpoint of one side of a triangle parallel to the second side, another side, bisects the third side. That means your O will be the midpoint of your BD. Because in this triangle DAB, from the midpoint of AD, that is E, a line is drawn that is your parallel to your OE is parallel to your AB. In that case, this line is going to bisect your third side. That means O will be the midpoint of your BD. O is the midpoint of BD. This we have proved till now. Now we will be considering triangle BCD. In this triangle, O is the midpoint of your BD, and if EF is parallel to DC, then OF will be parallel to your DC. That means this OF is parallel to your DC. Now in the triangle BCD, F is the midpoint of BD, OF is parallel to your DC. So if from the midpoint of one of the side of a triangle, we draw a line parallel to another side, then it bisects the third side. So from the midpoint of this side BD, we have drawn a line parallel to your CD, then it is going to bisect the third side. That means F will be the midpoint of your BC. This is how we can see F is the midpoint of BC, and that was only to be proved that F is the midpoint. So by using your converse of midpoint theorem, we can prove it. Now let's see question number 5. In a parallelogram ABCD, first of all I am making the figure, it is already given to you. ABCD, this is the diagonal, this is the point, and this is the point. This is your A, this is B, this is C, this is D, this is F, here it is E, it is P, it is Q. This is the figure. In a parallelogram ABCD, it is given to you that ABCD is a parallelogram. E and F are the midpoints of side AB and CD. E and F are midpoints of AB and CD. Show that the line segment AF and EC trisects the diagonal BD. That means what we need to prove is DP is equivalent to PQ is equivalent to QB. This we need to prove. That it is trisecting, that means your DP is equivalent to PQ is equivalent to QB. This we need to prove. Over here it is given to you that ABCD is a parallelogram. If it is a parallelogram, opposite sides will be equal and parallel. That means AB will be equivalent to your CD also, and AB will be parallel to, AB is equivalent to CD, and AB is parallel to your CD. This is the condition given to us because it is a parallelogram given to us. Now, if this is a parallelogram and E is the midpoint of AB and F is the midpoint of your DC. So, if this is the midpoint, that means your AE will be equivalent to EB and your DF will be equivalent to your FC. So, if AB is equivalent to CD, so half of AB will be equivalent to half of CD also, and half of AB could be written as your AE and half of CD could be written as your FC. That means AE is equivalent to your FC. Now, AB is parallel to CD. If AB is parallel to CD, in that case, your AE, part of your AB, will be parallel to your FC also. It is part of your CD. So, AE is parallel to FC, AE is equivalent to FC. So if in a quadrilateral, one pair of opposite sides are equal also and parallel also, then we say that it is a parallelogram. So what we have proved is that AECF is a parallelogram. This we had proved, that AECF, this is a parallelogram. AECF is a parallelogram. Now, if it is a parallelogram, so its opposite sides will be equal also and parallel also. So, AE will be parallel to FC, just now we have proved. So, FA will be parallel to your CE also. If it is a parallelogram, then AF will be parallel to your CE. These two are the opposite sides of the parallelogram. So AF will be parallel to your CE. Right? Now what we'll be doing is we will be considering triangle ABP. ABP. This triangle we are considering. In this triangle, E is the midpoint of AB. EQ is parallel to your AP, because if your AF is parallel to CE, so part of AF, that is AP, will be parallel to your EQ also. If your EQ is parallel to your AP and E is the midpoint of AB, so in the triangle ABP, this triangle we are considering, in this triangle, from the midpoint of one side, we have drawn a line parallel to the another side. So EQ is parallel to another side, then it is going to bisect the third side. That means Q will be the midpoint of your PB. Right? By converse of your midpoint theorem, in this triangle, from the midpoint of one side of a triangle, we have drawn a line which is parallel to another side. So it is going to bisect the third side. That means Q is midpoint of PB, or we can say PQ is equivalent to your QB. If Q is the midpoint of PB, then PQ will be equivalent to your QB. This is one of the part we have proved. Right? Now we will be considering in triangle DQC. DQC. This triangle DQC we will be considering. In this triangle, it was given to you that F is the midpoint of DC. Now from the midpoint of DC, that is F. Now again, because your AF was parallel to your EC, so part of it, that means PF will be parallel to your QC also. So this PF is parallel to your QC. Now in the triangle DQC, from the midpoint of DC, that is from the point F, we are making a line parallel to your one of the side of the triangle. That means from one side or midpoint of one side of a triangle, we are drawing a line parallel to another side. So FP is parallel to your CQ. Then it is going to bisect the third side, your converse of midpoint theorem. That means P will be the midpoint of your DQ. Now if P is midpoint of DQ, so what we can conclude is DP is equivalent to your PQ. This we can conclude. In the triangle DCQ, from the midpoint of DC, we have drawn a line parallel to another side CQ. So it is going to bisect the third side, your DQ. So P will be the midpoint of your DQ. And if P is the midpoint of DQ, we can say DP is equivalent to your PQ. If this is your equation number 1, this is equation number 2. So what we can say, PQ is equivalent to QB also, PQ is equivalent to DP also. So we can say PQ is equivalent to DP is equivalent to QB. PQ is equivalent to DP is equivalent to QB. This was only to be proved that it is trisecting. That means DP is equivalent to PQ is equivalent to QB. It was only to be proved, and this is how we can prove it. This is all from this chapter. Hope it is clear to you. It is clear what midpoint theorem is, what converse of midpoint theorem is, what is quadrilateral, what all properties of a parallelogram is, how we can prove it, and how to solve questions based on it. Soon we'll be coming with the more videos on another chapters of your class 9th maths curriculum. Thank you.